And the carrier is very large, and it has a large surface area so that the API would attach on the surface. And as you can see in the photo, the API particles attached to the large surface of the carrier. The production of the DPI, or the process used, is mainly prolonged mixing time and high mixing speeds. And the effect that we have by doing this long mixing time at high speeds, that we change the attraction forces inside of the materials. I will explain a little bit about this. So the materials, they have two types of attraction forces. The first one is the cohesion forces, or the cohesive forces, and the second one is the adhesive forces. The best example to understand these forces is the water droplets and the tree leaf. So the cohesive forces are the forces between particles of the same substance. For example, the water particles, they attach to each other, or they attract to each other, and this forms the shape of the droplet. So the droplet of water, it has the circular shape, and this is caused by the attraction forces between the water particles themselves. And the cohesive forces are the attraction forces between different substances. In this case, it will be the water particles and the leaf itself. So the materials are different, but for example, if you have a droplet on the leaf and you flip it down, the droplet will not fall down. And that's because there are the adhesive attraction forces between the water and the leaf. And the forces are mainly, they are called van der Waal in the cohesion attraction forces, and it's made of electrostatic attraction for the adhesion. So the mixing time is relatively long. So it takes 20 to 30 minutes, and it's only dry mixing. So there is no spraying of liquid to make any granules. And this mixing increases the electrostatic forces and gives the effect that the attraction between the same particles of the substance, which is the API, for example, they detach from each other. And the attraction forces between the different materials, which is the lactose carrier and the API, will increase and overcome the cohesive forces. And this will allow the API to attach at the surface of the lactose carrier. There are some parameters which you need to take in mind when you start a project for DPI. So from our experience with our customers, for example, inside of the mixer, there are two mixing tools. We have a big impeller and a small chopper that runs quickly. So some customers prefer to run only the impeller alone without the chopper. Some customers, they run both of them, so the impeller and the chopper. And the speed also, which is an important parameter, it's different from one customer to a customer, one product to a product. And for some customers, the products are sensitive to heat, and when you mix for a long time, the temperature of the product will increase, of course. And in that case, these customers would like to have a double jacket of the mixer, of the mixing bowl, so that you can do cooling and to control the product, the temperature of the product, so that it doesn't go above a set point. So as Diosna, we have a large experience with the DPI, and we have made many projects. So this is a short reference list, and as you can see, there are few references in Turkey. And we have a process lab at Diosna in the city of Osnabrück. And we invite always our customers to do some trials in our lab to make sure that our mixer is suitable for their process and for their products. Now I will talk about the machine itself. So just an information, Diosna was the first producer of the high shear mixers in the pharma industry. Before that, all of the mixers were ribbon blenders or low shear mixers. And until today, we claim that our high shear mixer is the best mixer in the market. And I will explain why, and the reason is in the details of the design. So this explains the design or the shape of our high shear mixers. So the design of our bowl is a big diameter or a large diameter and a short height. And this gives us the advantage that you can fill the bowl for a very large or a relatively large percentage, which is 90%. And for most of our competitors, they can fill it 2/3, for example, or 70 or 80%. So this is the advantage of Diosna, because you have a flat surface, so the product movement is good, and the chopper is at the closest location or very close to the impeller, so that all the product, even at low speeds, can reach the chopper and be mixed and be granulated in a good way. Also, the design of the impeller. So the impeller has 3 blades, and these blades are tangential. They are not perpendicular. And this gives 2 advantages. The first one, we don't have a dead area here. So if it was perpendicular, then you will have an angle where the product will stick and be lost. So we don't have this. So this is a dead area that we have eliminated. And also, because of the tangential shape or design, while the impeller is rotating, of course, the product will be rotating a big horizontal circle, and the tangential shape will be also hitting the product in an angle, so that it will rotate also a small rotational movement around itself. Also, the tip of the impeller has a big ear or a big tip, and this throws the product upwards. And when it goes up, we have a conical shape to throw it to the center. At the center, we have a big cone, displacer cone, which completes the circle. So the product will be rotating also vertically. So this way we have a 3-dimensional motion. So one big horizontal, also small horizontal rotations, and another vertical rotation. And this gives the best and fastest and most efficient mixing effect in a high shear mixer. And our mixers, as you can see, are bottom driven. And the advantages of this is that we eliminate also some dead areas. For example, the area below the impeller, we have a very small clearance. So at the center, it's around 1 millimeter only. And at the tips, it can go maximum to 3 millimeters. So this will scrap all of the product, and all of the product will be involved in the mixing. Also, because it's bottom driven, we don't have a shaft in the center. So no product can stick to the shaft and be lost as well. When the product is thrown upwards, if the shape of the bowl was cylindrical, then the product will reach a point of 0 speed. So it goes up, it stops, and then fall down. And we have the conical shape just before this 0 speed. So the product at its speed will be thrown to the center, and it will not stick at that point of 0 speed. So all of these parameters, all of these details gives the best mixing and best granulation effect. So this is our first friend. So this is the smallest high shear mixer that we have. It's called the P126. It's a tabletop machine, small. It can have interchangeable bowls starting from 0.25 liters up to 6 liters. The bowls can be normal or jacketed. You can have a side discharge as an option. You can add the liquid if you want to make granulation. You can add the liquid manually or using a spray nozzle. But let's concentrate now on the dry mixing, since it's talking about the dry powder inhalation. So these are the different bowl sizes that it has. And the batch size can start from 40 grams up to 2.7 kilograms at a density of 0.5 grams per milliliter. One advantage of the bowls is that they have lids which are mainly made of glass. And this is ideal for the laboratory or the R&D because you can inspect the process in a very good way and see what is happening inside. Again, this is the shape of the impeller and chopper inside of the mixer. And another advantage of Diosna, we have the same design and the same geometry for all of our high shear mixers. Also, the tip speed, which is one important parameter, is the same for all mixer sizes. And this makes the scaling up from the smallest mixer up to the very big mixer easy and without any problems. The P126 can have the default control panel, touch panel from Siemens with a PLC control. You can have manual mode and automatic mode to run the recipe automatically. And then if you want to have the ability to produce batch reports and audit trails, then a tablet PC can be also integrated. Then you will be compliant with 21 CFR Part 11. The next bigger machine is called PVAC to 10, and P means pharma mixer, and VAC means vacuum dryer or a single pot. So this machine can come in two versions. The first version is only a high shear mixer, and the second one is the single pot, which my colleague Michael will talk about in the next presentation. But for dry powder inhalation, I will concentrate only on the pharma mixer. So this machine is like the P126. It has the same 6 bowls, but in addition, it has also the 8-liter and 10-liter bowls. This machine is a little bit advanced, so it can be an ATEX design, not like the P126. So you can run processes with organic solvents or with dusts or products which are highly explosive. Of course, you can have also the PC, which you will see in another slide, to be compliant with 21 CFR Part 11. So the capacity we can cover is 40 grams up to 4.5 kilograms. And here's a photo of the different bowls. And of course, the bowls like the P126 can be normal or jacketed. The mixer lids are the same, made mainly of glass. They have the same shape, as you can see. The control, the main control or the default control is a PLC with a Siemens touch panel, and the higher end, which is an integrated industrial PC, complete with 21 CFR Part 11, and have all the abilities of batch reports, audit trails, the different access levels with passwords. And of course, like the P126 also, it's a standalone machine. It has all the drives, all the electrics and controls inside of it. And you can move it on wheels from one room to another. This machine also can be used for high containment, as you can see. So in this project, we have worked with the company EasyDock. We have designed a special feeding arm to carry the valve, and the feeding and discharge is done under high containment. And of course, we have a special filter for breathing so that we don't break the high containment. The next bigger machine is the PVAC 10-60. Also, it can be in two versions, as a normal high shear mixer or a single pot. So the high shear mixer version can have 3 interchangeable bowls, 10, 25, and 60 liters, which can cover the capacity of 0.5 kilos to 27 kilos. This machine is standalone like the small machines. It's movable on wheels, and it has all the electronics and the technical components inside of it. But on the other side, it's the first machine or the first size that can have the production abilities or the production functions. For example, I will talk in more details in the coming slides, but Mainly, this machine have a special sealing for the impeller and the chopper. It has it can have WIP cleaning, automatic cleaning, and it has also a GMP automatic discharge valve, pneumatically actuated. The shape of the impeller and the chopper, as you can see, is also the same. So the two small machines that I talked about first, they have mechanical sealings for the impeller and the chopper. The PVAC 10-60 has the same sealings which we use in the production scale mixers, which called air gap seals or air purging seals. So the sealing is based on compressed air. So this photo shows the area below the impeller. So after we lifted the impeller, you can see there are 3 holes below it, and this is the sketch of one hole. So these holes, during the process, during feeding, mixing, granulation, and discharging, they will be continuously supplying compressed air, or in case you have the nitrogen purge to eliminate or prevent explosions, they will be supplying nitrogen. And when the impeller is in its position, so like here, so this shows the impeller, and this is the opening. This will create a small or a very thin disc between them, and when you supply the compressed air, this area will be continuously flushed with the compressed air or nitrogen, and this will prevent that the product goes inside to the shaft and the sealing area. And of course, the biggest advantage of this sealing, that it's not mechanical like the sealings of the mechanical sealings, and there is no friction, or the friction is very minimal. So it's only at these 2 sealings, let's say, and the lifetime of this sealing is very, very long. During the cleaning cycle, the machine can automatically switch between the air and the water. So water can be supplied through these openings. The mixer can be filled with water to the half of it, let's say, and then run quickly so that it has the washing machine effect and clean the bowl from the inside. The chopper has also the same principle. So it has also some openings, and they are sealed with compressed air or nitrogen during the process. The machine is also movable on wheels, standalone. It has all the technical components inside of it. The simplest control is also PLC with a touch screen. Of course, it can have the industrial PC to be compliant with 21 CFR Part 11. As you can see, it's like the production scale mixers. It has inside membrane valves to switch automatically between the compressed air, the nitrogen, and the water for cleaning. So you need only to connect these medias to the machine, and it will do everything automatically. As an option, the filter on the mixer lid can have a special ring for cleaning. So this ring has small holes in it, and it sprays water or cleaning media on the filter before you remove it. And this is important in case you work with high containment conditions. And after you remove the filter, there is a special cleaning nozzle which you can insert, and it cleans, or it rotates to clean the area from the bottom area of the mixer lid. For high containment, we can install split butterfly valves on the mixer lid so that you can do the feeding under high containment. We can have also split butterfly valves at the outlet, and the exhaust air filter can have a connection to a technical area, which we can install a HEPA H13 filter, which can be automatically floated with water so that you can replace it without any danger. And since the balls are relatively large and heavy, so you can't replace them by hands like the smaller machines. So you need a sort of a lifter to help you carry them and store them. And then we start with the production scale high shear mixers. So these high shear mixers mainly they can be installed through the wall, so they can be attached to the wall, and the production area will be isolated from the technical area, and the mixer or the frame from the backside, it is open, so the operators can go to the technical area, inspect anything while the mixer is in production. The mixer, the standard mixer, which is non-ATEX, it's designed as atmospheric, so it doesn't have any shock resistance design, let's say. If you work with organic solvents or explosive products, then it can have nitrogen flushing or inertization to prevent any explosions. Or if it is connected to a fluid bed, and the fluid beds are, let's say from Diosna, are always in 12-bar design. So the mixer can be also in 12-bar design and shock-resistant design, so that if an explosion happens inside, it will be contained inside and no one can be harmed. Of course, the cleaning is automatic. We have the air purge ceilings, and we also developed a function or an option which is called Diosna tool lift system. So the impeller, and we will see it also in a photo in the coming slide, it will have a pneumatic cylinder below it. So after you do the cleaning, you need, of course, to make inspection to make sure that the cleaning was done in a good way and is validated. So instead of manually removing and lifting the impeller, you can go simply to the screen and touch a button, and then it will be elevated automatically by around 15 centimeters, and you can do the inspection and then click it again, and then it will go back to its initial position. Again, the impeller and chopper look the same. As you can see, here is the tool lift. So the pneumatic cylinder will elevate it like this, and you can inspect the bottom side of the impeller, as you can see here. And again, the air gap ceilings. So in this photo, you can see the ceiling area after actually multiple batches. So the customer in this photo has made more than one batch. And as you can see, after these batches, the area is totally clean. So no product is inside. The feeding of the mixer can be done in many ways. So it can be fed by gravity. The simplest way is just to open the lid and put the product manually. Or we can have a valve or a port to make the feeding by gravity. And if you work with high containment, then we can have also split butterfly valves. And with the help of a lifter, you can feed the product using gravity under high containment conditions. If you don't have high containment, then the most common is the vacuum feeding. So the mixer will have a vacuum pump in the technical area. It will be connected to the filter or the breathing filter on the lid, and this will create vacuum inside of the mixer. And this vacuum can be used to feed the product using this lance. We have also done like a vacuum feeding station. So we have designed this station to place some IBCs on them, and then after opening the valve, the vacuum will go and will take the product to the high shear mixer. For the cleaning, usually we supply a separate cleaning station in the technical area, and this cleaning station can be as simple as possible or as advanced and sophisticated as possible. So the simplest version is simply valves in the technical area. You can connect the cold water, hot water, DI water, compressed air, and nitrogen. And it will supply these medias to the different parts of the mixer automatically according to the cleaning recipe. We can have a booster pump to increase the pressure. We can have a detergent pump as well if you use detergents for cleaning. If you need to heat up the water or the cleaning media, if you don't have hot water, then a circulation tank with isolation and a heater can be also integrated in the cleaning station so that the heating will be done also automatically. And the control system, the standard one is a PC screen, a normal PC screen. You can see it here. It is through the wall, so we have a hole in the wall, and then we have a glass with a stainless steel cover, and then a membrane keyboard. And as an option, we can have also touch screens. The visualization of the mixer. So this is a screenshot. You can see the main parameters all the time, and you can see also the step or the section of the recipe which is now active. And the recipe looks like this. So you can have multiple steps, and in each step you can define the runtime or the duration of it, and the different parameters, speeds, dosing, in case you have a pump for spraying, and of course at the end you can have the battery port and yeah, everything you need to know about the process that you have done. And I think I have saved 5 minutes, so maybe you can use them for questions if you have any questions.